Hi everybody, this is part 2 of your quadratics intro unit. In our learning goals from this lesson, be able to identify quadratic data from tables, graphs, and equations. And we're going to start drawing some simple parabolas given the vertex, zeros, and y-intercept. During the last lesson, you guys learned about the key features of a quadratic, and it's called a parabola. And then what are the key features of the parabola? We're going to build off that. Graphing is a skill. You're going to have to do lots of it throughout this course. So for this first example, it's kind of a warm-up. The table shows a soccer ball's height above the ground over time after it was kicked in the air. Part A, graph the data and draw a smooth curve. So to get you started, because I'm going to ask you to pause at some point. Time is going to be your x-axis. Height is going to be your y-axis. And then I'm going to ask you to make a scale. So I'm going to ask you to make a graph where time goes along the x. And since they all go up by 0.5s, your graph can go up by 0.5s. Height, though, height doesn't go up by a regular pattern. So I'm going to leave it up to you to make a proper scale. Again, making a scale in a graph is very important. Depending how big the graph paper you use is, or if you're doing it on blank paper, depending what your scale is or how many lines you have, you might have to go up by 1s, you might have to go up by 2s, 5s. I mean, the highest you have to go is 13.8. So probably for most of you, going up by 1s or 2s will work. And then you kind of guess, you have to estimate where your point would go. So at this point, I'm going to ask you to pause the video, make a graph, time on the x, height on the y, give your graph a title, plot the points, connect them with a smooth curve, and then hit play again. So if you hit pause and you're rejoining us, welcome back. Now your graph, now just ignore that x and y, so I'm going to erase that. Hopefully your graph, depending on your scale, but hopefully your graph looks something like this. And you gave your graph a title. Let's just say we called it, I don't know, soccer ball height. But whatever you called it is fine. And then you labeled your y-axis as height. And don't forget to include the units meters. And then your x-axis was time in seconds. And even though it's not a smooth curve, yours more or less should look like that. Describe the shape of that graph. Now you could say like a hill or a bell shape, but we have a word now that we know. And we know anything like that's kind of parabolic in shape. So just to describe the shape of the graph, you could say a parabola. And we could even go further than that in using some words from the first intro. Does it open down or up? It opens, hopefully you're saying it opens down. What was the ball's max height? Well, we can look at our table, look at our graph. Looks like it's just under 14. If I remember the number in the table, I believe it was 13.8 meters. So remember, the max height is the highest your graph gets. So just make a little note there. There's the max. How long was the ball in the air? So in other words, when does it come back down to the ground? Now our graph didn't go all the way down to the ground. So what you have to do right now to your graph is do your best to follow the pattern or the trend. So I'm just going to make a dashed line. And for me, it looks like roughly that's where it hits. Now, my scale is going up by 1s. So 1, 2, 3, 4, 5. For me, it looks like roughly, and this is just an educated guess, but everyone should be within, a couple decimal points of where I am. Between 3 and 4, we could say roughly, 3.4 seconds. Now, if you graphed and scaled the table of values correctly, you should have got something between 3 and 4. So if you got something between 3 and 4, give yourself a high five. If not, then we've got to go back to the drawing board and we're going to say, okay, where did I mess up my scale or my graph? So we know that if it makes a parabola in shape, we know that it's quadratic. The next part of this is, how could you, like without graphing these, how could you just look at the equations to tell if they're quadratic? So that's the next key to this lesson. So let's start with A. Some of you may or may not recall, but y equals 3x plus 4. That's like, grade 9 and grade 10. Y equals mx plus b. Does anybody remember what kind of graph y equals mx plus b is? Well, it makes a straight line, which means it's linear. So that's definitely not quadratic. The next one, B. 2x squared minus 5x plus 3. We maybe have not seen something like that before. Definitely not y equals mx plus b. It's not linear, for sure. What I am going to tell you, though, is I'm just going to let the secret out. This is quadratic. Okay. Now to build our definition, so I just told you B is quadratic, and maybe hopefully you're thinking, what's different about B than A that makes it quadratic and not linear? Well, hopefully you're saying, well, it's got 3 terms. Okay, good idea. But the big thing is it has a squared, an x squared. So the first one, A, linear, does not have an x squared. B, though, has an x squared, and I just told you that makes it quadratic. I'm going to skip down to E. E has an x squared, but it also has an x cubed. And I'm going to let the secret out. This is not quadratic. Excuse that from time to time. The pen drags. Not quadratic. In fact, and you don't even need to know this, it's cubic. So to help build our definition of what makes something quadratic, we know that B is quadratic, it has x squared. E, I've just told you, is not quadratic, and it has an x squared, but it also has an x cubed. So our definition of what makes something quadratic is not only does it have to have x squared, but x squared has to be the highest exponent. So this is important. So if you just look at the equation, it's quadratic if, so it has x squared and it has to be the highest exponent. Meaning that 2 has to be the highest. So that's important. Make sure that you highlight that. So for something to be quadratic, it has to have x squared, and x squared has to be the highest exponent. So it could have an x squared in it like E does, but since the 3, the x cubed, is bigger, it is definitely not quadratic. If we look at C, there's only one term, that's okay. Does it have x squared? Check. Is x squared the highest? Check. Quadratic. D. Does it have x squared? No, so it's not quadratic. And in fact, this is linear. Makes a straight line. Now while I'm here, I just remembered I wanted to say something. I'm not sure if I told you in a previous video or not, but a lot of the pre-recorded videos that you've been watching or you will watch, they have dates in them and they reference things because they were recorded in a previous quadmaster. So just the content is more or less the same. If I reference things like have a good weekend or good morning and you're watching this in the afternoon, or it's Monday or Tuesday, ignore all that stuff. Just pay attention to the actual content, the lesson itself that you're copying, and don't worry about the dates. And if an achievement check pops up, don't worry about those either. You just do the lessons, and we'll talk more about achievement checks when and if we get back to face-to-face learning. But I just wanted to get that out because I wanted to say at the beginning, I forgot, but I remember now. Now we're going to move on to drawing some simple parabolas. So all you need to do is make an x and y axis. So let's do that. Remember, x is horizontal, left and right. Y is vertical, up and down. If you have just a ruler, straight edge, make your x and y axis. And then make sure you make a scale. I'm going to go up by ones. 1, 2, 3, 4, 5. Negative this way. 1, 2, 3, 4, 5, 6, 7, 8. And negative going down. -1, -2. Okay. Number 1, draw the parabola with vertex 3, 4. Vertex, that's one of your key features, one of your key definitions. If you don't remember what the vertex is, go back to the first note and re-look it up. But remember, the vertex is kind of the changing point of your parabola. It makes a max or a min. Middle, you know, your axis of symmetry goes to the vertex, cuts your parabola in half. So 3, 4, you have to plot 3, 4. 3 on the x, 4 on the y. So 3 on the x, 4 on the y. Right there. Zeros, again, if you don't remember those features, go back and review them from the first intro lesson. Zeros is another word for x-intercept, which means where your graph or where your parabola touches the x-axis. So at +1 and +5. So there's my x-axis, +1, +5. Now you may laugh, but there are people that still probably don't know how to connect this to make a parabola. There is only one logical way to do this. Now hopefully you're thinking this is a parabola that opens down. We know our vertex is either the highest or lowest. In this case, where my zeros are, that's got to be the highest. So just make a little sketch that looks like that. And there is our rough drawing a simple parabola. We're going to get more specific with these in future lessons. And I'm going to label that number 1. Number 2, draw the parabola with vertex 0, -8. 0 is at 2, -2. So vertex, start there, 0, -8. So 0 on the x, -8 on the y. So that's all the way down here. 0 is another word for x-intercepts. 2, -2. And again, there's only one logical way to make a parabola from this. And hopefully you're thinking it's one that like opens up, looks like a U. So I'm going to connect those. Again, make sure you have arrows on the ends. And label that number 2. And we've just successfully drawn 2 very simple parabolas. The last thing we are going to do for this lesson, getting key info from a graph. Now if you want to, you can pause this and just make a quick sketch of that graph and then unpause and come back. So looking at our graph, what is the vertex? Hopefully, and again, if you don't remember, refer to your key features from the last lesson, but your vertex is like the absolute minimum or the absolute maximum. In this case, the minimum. Kind of the very bottom of our graph, right there. There's our vertex. That has coordinates 3, 1. So our vertex is 3, 1. Optimal value. Again, go back to your definitions if you don't remember. The optimal value is the lowest or highest your graph gets. It's also the y-coordinate of your vertex. So the lowest my graph gets, that's the lowest it gets, y equals 1. And if you remember, as long as you can pick out the vertex, which is definitely a key learning skill for this unit, you have to remember that the optimal value is the y-coordinate of the vertex. The axis of symmetry. That's the line that cuts your graph perfectly in half. Where does it go through on the x-axis? At 3. X equals 3. Again, as long as you can remember the vertex, the axis of symmetry is always the x coordinate of the vertex. So just to reiterate, 'cause that's important for learning, if you can pick out the vertex, the y coordinate is always the optimal value. The axis of symmetry is always the x value. Zeros. Where does this parabola cross the x-axis? A little bit of a trick question. Does this parabola cross the x-axis? It doesn't. So are there any zeros? None. Opening. Your options are up or down. If it makes a U shape, the word up starts with U. This looks like it makes generally a U shape. It opens up. If it opened down like a hill, then it would be down. The y-intercept, where does this cross the y-axis? We'll just assume, to make it easy, it crosses right there. So what coordinate is that on the y-axis? 7. So what are the coordinates of that? 0, 7. Or you could write y-int for y-intercept, that's short form, equals 7. So there's all your key information from a graph using the definitions from the first intro unit. And that's it in terms of the second intro unit. And you've now successfully completed the lessons, the first 2 lessons from this first unit on your first day of Quad 3. And by the time you've watched this, they've probably already announced when we're coming back. So I'll probably be seeing you face-to-face after Family Day, and then you still have a couple more lessons to work on, a few more lessons actually to work on tomorrow, and then don't forget you can now work on section 1.1, questions 1 to 3 from your workbook. Remember, your workbook is in the content section under workbook. Don't bother printing it. You'll get one given to you when we return to face-to-face learning. And you have a diagnostic assessment for bonus marks that you have to hand in. That's due 10:35 on Friday morning. Don't forget to get your signed forms in by you and your parents. Uploaded them, getting practice doing that. And then you have your first quadratics assignment if you've looked ahead. You've had your first assignment, which you could start working on at any point. But you're probably going to want to watch tomorrow's lessons first, and that's due Sunday by 11:30 p.m. Talk to you tomorrow.